There are a variety of ways you can tell that triangles are congruent. We're going to learn about 4 of them that work for any type of triangle. When we look at congruent triangles, we abbreviate the theorems using the 3 letters indicating the types of pairs we need. The first way is side, 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 SSS. To use SSS, or side, 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 we need to know that all 3 pairs of sides are equal. In the diagram, you can tell that by the little marks that they've used. You'll often see then the triangles named. We can in this case say triangle ABC is congruent to triangle XYZ. When we name the triangles, it's important that we pair up the sides that have the same markings in the correct order. The next way we can prove that triangles are congruent is with side, angle, side. That means that we have 2 pairs of sides that are equal, and the angles in between those sides are also equal. A lot of books will refer to these as included angles. By included angles, I mean the 2 that are touching both of the sides that have the given mark or the given measurement. In the picture here, it would not be enough if we only knew that angle B and angle Y were congruent instead of angle C and angle Z. Once again, the angles have to be in between the 2 sides that are marked equal. Our next 2 are pretty similar. This one is called angle, side, angle. Here we have 2 pairs of angles that are equal, and once again, it's the sides in between them, or included, that are equal. You can think about going just in order that one touches the next, touches the next. So first we have angle, touches a side, that side touches the next marked angle. That's ASA. Compare that to angle, angle, side. Here we also have 2 pairs of angles that are equal and a pair of sides that are equal. But this time the side is not directly in between the 2 angles. Angle, angle, side. The 2 angles are right next to each other. The side is off by itself. It's only touching one of them. Let's look at some examples. In the example at the top, let's see if we can figure out if those triangles are congruent. A lot of the times it helps to write down what you have marked equal. We have marked that AB is equal to DE. I know that because each of them has one little slash through it. EF is equal to BC, and DF is equal to AC. I can't assume anything else is equal, even though the sides, or the angles, look similar. But since I have 3 pairs of sides that are equal, these triangles are congruent by side, side, side. Looking at the ones in the bottom, let's again write down what we have. I know that angle A is equal to angle X, AB is equal to XY, and CB is equal to ZY. I have 3 pairs of equal parts, so maybe I have enough to prove that triangles are congruent. Could this be side, angle, side? No, these are not congruent. Side, angle, side would mean that I had the angle pairs that were included between the 2 marked sides. Notice how my angle pairs are off by themselves. We do not have something that's called side, side, angle. Remember, if you write down a reason and it spells a bad word, that was not correct. Sometimes on your pictures, they're going to give you measurements to indicate that the sides or angles are equal. Looking at the top picture, we have 2 sides that are 4 centimeters long, 2 sides that are 5, and an angle pairs that are 100 degrees each. This is congruent because of side, angle, side. In the bottom, once again, we have 2 angle pairs that are the same size, a 65 and a 75 degree angle, and then 10 centimeters as our side. These are congruent because of angle, angle, side. When you're trying to figure out if the triangles are congruent, start by writing down what you have pairs of. Count the number of pairs, you need 3, and look at the locations.